voltage. We know what they are. We know how to look at them instantaneously. We're not going to look at them over time. That's a different class. So we're going to measure everything instantaneously. So when you put your meter on there and you say, it's 12 volts at 2 amp, what you're telling me is at 1241.065, you measured it and that's what it was. But at the point that you told me about it, it might be a slightly different, okay? So instantaneous, that's what we're doing, okay? All right. We can control our electrons by controlling the voltage and the current. We do that by using multiple devices. Today we're talking about resistors. Resistors do that by resisting the flow and producing heat. Okay? Why would I use a resistor in a circuit? Why would I care? Why wouldn't I just use a switch?
Wouldn't want to burn something up down line.
You could.
Different voltage requirements on the board.
If I had a light bulb that was 6 volt and I had a 12 volt power supply, I could use a resistor, couldn't I? And what would it do? Well, the light bulb would light up because the tungsten, when it starts to heat up. Oh, what is it about tungsten as a resistor? What's cool about that? The light bulb looks like almost a short. If you put a ohm meter across it, it looks like 1 or 2 ohm, right? But what happens when it heats up? Physics, guys, physics. What happens to tungsten as it heats up? What happens to the resistance? It goes up. So what happens is, it starts out looking like a direct short, but as soon as it heats up and starts emitting light and heat, the resistance goes up. So it self-regulates. In fact, you guys probably never did this. Probably just put the battery charger on the battery and it automatically did everything for you. In the old days, we didn't have a lot of battery charger, Wazoo battery chargers. Didn't have any for a while. The original battery chargers would charge 6 and 12. They'd charge all kinds of configurations. And the reason is because it had this little bulb inside with mercury in it. And the transformer was good for like 24 volts. And then they run it through that little bulb, and when you hooked it up to the battery, that would self-regulate and charge the battery. Now, a trick we used to use was if we needed to do a 6-volt battery, we'd take a 12-volt charger, and then we'd take a car headlamp, we'd hook it in series with the charger and the battery, and the headlamp would glow while the battery was charging up. When it charged up, the headlamp would go out, and we know it was charged because there was very little current. The light self-regulated with the tungsten in the light, okay? So it would charge up the battery, and we could tell when it was charged up. Okay? So some materials actually change resistance depending on how hot they are, like in a light bulb. Now, you can't have air in there because what happens to that material? It oxidizes and burns up. Okay, so it's a gas or it's or it's just a vacuum. Okay, depends on the light bulb. Okay, all right. So that's where a resistor does work all by itself. Can I use a standard resistor? I could, a high watt resistor, so it'd pass some current. It would pass the same amount of current as the load required. A battery requires less as it charges up. If I was using a light and a resistor, the light would come up to the resistance that would match the resistor, and the total resistance should match the power supply, therefore the light would not burn out. Right? Okay, so that brings us to a thought about lights. If you're going to control the brightness of a light, you can use a very large, this thing's going crazy, I think it's getting short of power. If you're going to control a light, you have to use a large variable resistor, right? because a light draws, well, a regular light draws about 1 to 2 amp, maybe 1 amp, let's say. Okay, so your resistor, it has to match that load so you could turn it up and down. When you get all the way up, then there's no resistance and the load isn't bright. But as you turn it down, the light bulb, let's think about how it works. The light bulb, here he is. But it has to be a variable resistor. You guys understand variable resistors? Okay, so it can't be a little, it's got to be some big, like a rheostat. You studied those with Bill, I'll bet, rheostats. And they're heavy, aren't they? Big old honking things. Cost a lot of money. Even for 1 amp, pretty good size. So if I attach it to my voltage and I start to adjust it, immediately it has to dissipate the power that the light is not going to dissipate. So if I want my light at half brightness, the other half of that energy has to be in that resistor, and it's going to give it off as heat, isn't it? Right? Okay. So, I can use a really large resistor to control my light, or I can use an electronic circuit, like a lamp control, right? Now, years ago in the theaters, they had honking. I've got some that are this big around at home, and a big old knob on them, and they turn them up and down so that the lights on the theater floor would go up and down, and they were massive. Some of them were transformers, some of them were just resistors, big old massive resistors. They were really cool. I collected a couple, 3 of those because there's not many of those around. They have the big old wooden knob with an arrow on it that you turn. Took like 5, some of them even had wheels on them. Took like 5 guys to turn them, you know. So, okay. So, we're going to learn how to control something like that with a circuit instead. Okay? So instead of a pure resistive load. Now, you can run into this out in the field. You can run into resistive problems. First thing is, you might run into a situation where it's really old equipment, like in a theater, and you have a big old resistor. And you got to figure out, is there something wrong with it or not? Or you might run into equipment that gives you trouble. I had an occasion one time where we had an FM repeater up on a hill. And what it does is service this area that was dead, you know, because there's always, when you have little FM stations, they don't put out a lot of power. And so there's dead spots in various places. So they put up a repeater that grabs the signal, amplifies it, and then retransmits it so people can get it on a different, and it's a different frequency, like 101 on the dial, and then it might retransmit it at 104, and then everybody can just tune into 104 and get the same music, okay? We had one on a hill, and it kept burning up. And they brought it into me, and I fixed it. Then they brought it into me, and I fixed it. And about the 3rd time, I go, you know, this shouldn't be burning up. There's something going on, you know. And they're like, well, you didn't fix it right. Well, yeah, I did. Worked fine for like 4 days on the bench. They took it out, put it in, and a week later, boom, it was burned up. So I said, you know, I should probably go out to the site and take a look at it. So it was a drive up on top of this hill on a rock somewhere. But I got up there. And so I went in, took a look at it. It was functioning okay when I got there. And I looked it over and checked everything, you know, and the cable was coming in and everything and had power, and, you know, I was just about to leave. And it was a cold day. and there's a little electric heater sitting on the floor. And of course, I'd opened the door and closed it enough times so it got cold in there. Well, that electric heater came on, and immediately that transmitter stopped working. And I go, oh. So you know what happened? It turned out to be really simple. There was a 220 volt line coming in. If you have a 220 volt line coming in, what's that third wire? It's a neutral or ground, right? Correct? Well, it was a very windy spot, and the wind had broke that neutral. When they wired the shack, they just had the transmitter and they had the heater, and the breaker box had a breaker for the transmitter and a breaker for the heater. And they just split it on the 220 on each side. Well, that was fine for the transmitter and the heater as long as the neutral was there. When the neutral went away, they balanced each other. And it was just enough so that this worked just fine. But as soon as that heater came on, which one was the bigger load? The heater. And this got 220 volt, took it out just like that. So, it was a neutral issue. It balanced up until that heater actually came on. There was a light bulb. I should add that to you. There was a light over here in the shack. I forgot to tell you that. And it balanced with the light bulb. There was a 100-watt light bulb and a 100-watt transmitter. It drew 100 watts or 82 watts or something like that. So they balanced up. As soon as that heater came on, boom! It was like a direct short, 220 volt across the transmitter, blew it up. Just like that. So it was a resistance issue. The light bulb was the right resistance. The heater wasn't. That's what you run into. So you will run into resistance problems. I don't know how many other guys they'd had up there. And I just caught it on the way out the door. Heater comes on, boom, tears it up, and I go, oh, look at that. And I go outside, and it's just flapping in the wind. Anyway, so, all right, so you can run into resistive problems that can create some real issues for you. Pure resistive problems. That was a purely resistive problem involving some complex electronics, okay? So back to what we were talking about. Voltage and current and resistance. They're all related. If one's out of whack, the others are out of whack. So if your circuit's having a problem, you need to go back to the basics. What are we doing? Control electrons. How do we do it? Voltage, current, resistance.